Okay, so now it's time to introduce the second speaker. Would you like to do it, or should I go with it?
You go.
Oh my God, no. Okay, I'm just joking. So our next person is a really, really awesome person because she is here to tell us about all the intricacies of spaCy. For those who don't know what spaCy is one of the most used uh, Python libraries. And Sofie, as machine learning and NLP engineer at Explosion, will share with us what to expect from spaCy version 3. And
Okay.
before we start, we have the first question. Sofie, it's a secret question. I'm not allowed to ask it, but anyway, I will do it. I will dare to do it. So the question is about your wall. What do you have on your wall, Sofie?
I mean, it's quite obvious that Guido and we had this. We synced on the bookcase stuff, so I think it's mine should be a bit more impressive still, but I did my best to match it a little bit. Also, a lot of sci-fi in there.
Oh, cool.
Sci-fi for the win.
All right, so shall I share my screen?
Share. Go.
Do you guys see it okay?
Yeah, we see that. It says
Yep.
spaCy. Then it says this and number 3.
Perfect.
Oh,
Okay.
No, we don't see it. It was
You don't?
there.
It's
Yeah,
going.
now we see
It's
it.
there.
Yeah, it's
But we
there.
need Sofie.
Yay. Yeah, that's it. Awesome.
Yes? Are we all set?
We are all ready.
Cool. So thanks for the introduction, Tanya and Aljona. And also thanks for the invitation. I'm really honored to be here, even though it's a virtual meetup, and it would have indeed be much more fun to meet you guys in person. It's still great to be here in this Python session. And I will be talking about spaCy version 3, 3.0, that we actually released 2 days ago, so last Monday. And during the talk, I will be focusing also on the design decisions behind spaCy. So hopefully it will bring some interesting points as well for those of you who may not be working on NLP or machine learning. And for those of you who are, I'll give you an introduction to V3. So hopefully there's a bit of everything for everyone. So first, to get everybody pretty much on the same page, what is NLP? So just broadly speaking, natural language processing is about extracting structured knowledge from unstructured language. And there's plenty of use cases where you can use NLP in various business cases. I think one that we can all relate to is if you're buying something online and there's plenty of reviews there. So, for instance, this example snippet here, where somebody says, well, you know, they say some things that are not so great about this product, and some things that are positive. So this is called sentiment analysis. You typically want to find out what the things are. For instance, the soundbar, they're not so positive about, and the LGTV itself, they are positive about. So these kind of things you want to be able to pick up on, not just as a consumer, but also as a producer of this type of product, of course. Another use case that I worked on while I was working on BioNLP is mining clinical trials. So clinical trials basically summarize how well a certain treatment was for a group of patients. So in this case, it's about a cancer trial, and they are measuring how well patients are responding to a certain treatment. And these kind of things are often written out in full texts in abstracts. But then if you want to find out which treatments are better for which kind of groups of patients, you basically want to be able to mine all of those different articles and go through them and bring out the crucial information with NLP and sort of summarize it in this kind of tabular format that you see here. So you can imagine that once you have that tabular format, it becomes much more easy to then process that in downstream applications. So introducing spaCy. spaCy is an open source library for industrial strength natural language processing. And it's one of those hybrid systems that Guido was just talking about. So a lot of, or at least some of the core classes in spaCy are written in Python. So this allows you to write a sort of C-style syntax that gives you much more let's say, control over your memory usage, so you can program things much more efficiently, while at the same time it also interoperates perfectly with Python. So a lot of your API and user-facing API can be in Python. So it's this hybrid system, and it's being maintained and has been released since 2015 by the company Explosion, that was founded by Matthew Hannibal and Ines Montani. Like I said, in 2015. So it's been around for almost 6 years now. And I think, so as was said in the introduction, I think it's indeed a quite popular library. We have more than 26 million downloads by now, and more than 19,000 stars on GitHub. So I think that's nice. And you can see, sorry, you can see the URLs on the slides as well. So spaCy is being developed pretty much as a developer tool, and I think this is a crucial point to make. And if you're trying to understand what spaCy is about, because myself, I've been working at J&J, so Johnson & Johnson, the pharmaceutical company, for quite some years, where I was working as an NLP engineer as well. And we would often look at vendors and open source software to use for NLP challenges. But we also wanted something that we could extend and customize ourselves, because natural language processing is always about adapting to a specific use case and addressing in-house needs. So I think that is an extremely crucial part of offering this open source library, is making it extensible and programmable by other Python developers. And this is why, as we're developing spaCy, we're always carefully thinking about the design choices behind the API, about consistent naming, good error handling, and of course, great documentation. So for those of you who are not familiar with spaCy, definitely go check out the documentation at spaCy.io. And those of you who do know spaCy, we've actually added quite a lot for the V3 release. So there's plenty of new stuff to read for you. So when we're talking about a developer tool, I just wanted to share one example that I think illustrates this point really well. And it's an example that was presented by Ines in her keynote speech at PyCon India. And the title of the speech was "Let Them Write Code." So I think that's a very, very nice slogan, and I'll try to do justice to her example here. So imagine that you're writing this NLP library, and you're thinking, well, we could implement this function that's called get all verbs. This sounds pretty intuitive. You'll write this function, get all verbs, and basically the user will be able to run a sentence through it, and they will get back all the verbs in that sentence. So we could program this, and we would get as an output in this particular case the words are, going, swimming, should, and go. So that seems rather straightforward. But then maybe some user says, well, that's fine, but some of these verbs are auxiliary verbs. I'm not so interested in those. Let's add a Boolean flag to remove those from the results, so we can add this kind of Boolean flag. Sure. Another user comes along and says, well, going, go are really two inflected versions of the same verb, to go. So maybe I just want to see, the base form of those words. So this is what we call lemmatization in NLP. So fine, we'll add another flag, lemmatize is true, and we'll present the lemmatized versions of these verbs. And maybe somebody says, well, let's also remove the duplicates, because that's more useful in my specific use case. So I think you're starting to get the gist here. You can basically keep adding these kind of Boolean flags to accommodate for people's different use cases and so on. And maybe at some point you'll also think, well, let's have a get all nouns function, because that could be quite interesting for people as well. And this get all nouns function will then have different Boolean flags, and you need to remember all of the flags and how they're spelled, what their defaults are, and so on and so forth. So as you can imagine, this starts to get quite detailed, and you're starting to get quite a lot of specialized functions. So this is very specifically not the way that we think this should be dealt with, and it's also not how we're dealing with this in spaCy. But instead, what we believe in is that you should provide the building blocks to the people who can then, or to the users who can then just go and use Python to filter and perform any other operations that they'd like to do. So for instance, in our case, what we'll do is a certain token or word in a sentence will know what its lemma is. It will also know what its part of speech or BOS tag is. And then as a user or programmer, you're just able to get all of the information, use the building blocks, and do the filtering yourself. So for instance, the duplicates thing, you don't need to have a Boolean flag for that. There's just a perfectly fine set operation in Python that you can use. So if you know Python, the idea is that you can help yourself and basically program this yourself. And I would definitely recommend watching the whole talk by Ines, because I'm sure she explains it much better than I do. So going back to this example where we run this sentence through an NLP function or object, I just wanted to show you a little bit how this is done behind the scenes in spaCy. And you can sort of think of this as an assembly line. I kind of like that metaphor. So you start with a text. Let's just say the simple sentence, I like John Lennon, and you start applying processing components to it. So the first component in our pipeline would be a tagger. This tagger is basically part of speech tagger that will assign part of speech tags to each word or each token in the sentence. So for instance, like is a verb, and that's the annotation that the tagger adds to that token. Next in line, you could have a dependency parser that will look at the grammatical relations between two tokens. So in this case, for instance, it will say, well, I is a subject of that verb like, and it will parse the whole sentence into the sort of graph-like structure. And we could also have, for instance, a named entity recognizer that sees that John Lennon, these two tokens or these two words together, refers to a person that is a named entity in natural language processing speech, and will assign those two words to that person entity. And you can assemble these kind of pipelines any way you like. You can swap in other components. You can write them yourself. Each of these components can be machine learning based, they can be rule based, or they can even be simple functions. And it all basically depends on the use case that you're trying to solve. So you might be wondering, fine, this sounds all nice and dandy, but how do I get my hands on one of those pipelines? There's two different ways in which you can get one of those pipelines. The first one is really easy. We basically have trained many pipelines out of the box for you, and we're distributing those, and they can just be downloaded with the CLI spaCy command, download command. And if I'm not mistaken, I think we have more than 55 trained pipelines currently available for download, and those are in 17 different languages. So chances are that you'll find something that could be useful to you in a language that you're interested in. But of course, you always have to remember that these pipelines, they are pre-trained, and even though they contain state-of-the-art components trained on generic text, they might not always suit your use case the best. So it's very easy to use these. You can just load them in your script and run a sentence through them. It's easy to install, and you can do some quick prototyping and experimenting with them. But honestly speaking, I think that the most interesting part about doing natural language processing is always finding a custom solution for your specific use case. So, and that means you'll probably want to do the second thing as well, as you dive deeper into NLP, and that is train your own pipeline. So, and this is one of the first things that is very different in spaCy 3 as opposed to the previous version, spaCy 2, is the fact that we've created this spaCy train CLI command that is really powerful. It takes a config file where you will have all of the settings, and I will come back to this extensively later on. You'll also be able to define your own registered functions and so forth. And then, as I said, you'll be able to train this pipeline on your specific custom data sets. So this is extremely powerful. And so I think this do-it-yourself, let's call them trained pipelines, can be very powerful for to solve your use case. Now, as machine learning goes, I think this XKCD comic is actually quite accurate. They're wondering how how does machine learning work? Well, you just stir this pile of, let's call them pile of data or pile of parameters long enough until the model starts looking right. This is kind of accurate. So this step is actually the most fun to do, I think, the stirring of the pile, or the experimenting with your config file, with your settings, with your data, and how you should define everything, what kind of layers to use, and so on and so forth. So this particular step may take some time, but it's also, I think, the most fun bit. So let's say that after some experimenting, maybe some weeks, you've been able to come up with this configuration file that is really working for your specific system. That is really just only the first step in bringing this model to production. So in this first step, you have your final configuration file, you'll train it, and then you can package it with a spaCy package command that will just take the best model and turn it into a pip installable Python package. And this is extremely convenient because now you can just share that Python package with your colleagues or however you like, and people will be able to load that custom package just like they would load one of the out-of-the-box pipelines that I talked about earlier. So the way of using this package is exactly the same as one of the pre-trained ones. So I just want to so let's just circle back a little bit to that comic where we're standing on top of the pile of parameters and trying to stir it just right. And I just want to show you a little bit of pseudocode, how some of this machine learning code might look like. So typically, you might be creating a tagger component, for instance, one that assigns part of speech tags. And what you see here in the slide is that basically when you make this tagger, these functions, they all have sorry, I lost track of my thought there for a second. So what you see here is that when you're calling this make tagger function, you'll actually get in some default parameters. In this case, you're not defining the depth parameter, so you will automatically get the default depth is 4. But if you look closer, this function will then go on and call another function called createModel, which has another depth parameter, which has another default value. And I'm pretty sure I know what you're all thinking. Well, it's pretty obvious in this case that the depth is 4 because this is the first default that is being hit. But I can assure you, if you have a code base full of these sort of hidden defaults and overriding defaults, it becomes quite difficult to see which parameter is being set by which function. And then at the end of it all, it can be quite hard to understand what kind of parameters went into the training of your model. Notice that there's also a hidden parameter here that the user can't even set. It's just defined, but there's no way in this case to be able to set it for the user. And what you see here as well is that this is a sort of, you can call this a top-down configuration because each method, each function call is calling another function and passing on the parameters as they've been passed on by the user. So it sort of trickles downwards, and you have to be able to find the path of that to understand which parameters were set how. So we basically thought about this for some time when we were developing spaCy 3, and we came up with a solution for this that defines the parameters quite differently. So the configuration file is now being stored, or all of the parameters are actually now being stored in a configuration file, where you can see a small snippet here. And this is sort of similar to a YAML file that is being used in. I got distracted. This is obviously not a YAML file. This is pretty much based on the config parser that's available in Python itself. But we've added a few options to it. So the structured sections are the same, and you're able to denote subsections with a dot notation. But then you can also register your own new functions. So these registered functions you can see here are defined with an notation. In this, and I'll come back to this in more detail later on because it's a really cool feature that I definitely want to show you further. But let's just walk through the configuration file a little bit further because you can see, so each section can have a subsection and so on. And what will happen when we resolve this configuration file is that each subsection will basically resolve to an object, and this object will then be passed to the superseding section, let's say, as an object. So in this case, the learn rate will be defined by this warm-up linear schedule. And this schedule then will be passed, so this learn rate object then, once it's completely resolved, will be passed on to the Atom function as a parameter. So I hope you can appreciate, I think this is kind of, I hope you can appreciate that this is completely the other way around, as we've seen on the previous slide. So in this case, the parameters, such as the warm-up steps, is only defined once in the block that actually needs that parameter at that time. And then the whole object is being passed onwards, rather than giving the parameter from function to function call. And this also means that our configuration file is basically a single source of truth, and it will greatly help in reproducibility of your experiments. One other thing that we added, which I think is quite useful, is variable interpolation. So you can have a section in your configuration file, such as vars in this case, where you define your variables that you want to reuse. So let's get back to the registered functions that I mentioned on the previous slide. And this is another snippet of a configuration file that looks a little bit like the previous one, where you see again this at architectures notation. And what this means is that spaCy will go into something called a registry and look for this function. So the registry in spaCy really just maps a string name, for instance, custom neural network.v1, to a function. And in this case, the function is custom neural network. And the way we do it like this, the reason why we do it like this is because you really don't want to start programming into the configuration file. You want to be able to express all of your logic in Python, because we're all developers and that's what we're good at. And then you can just refer to those functions from the configuration file. And this will also help with I/O and other things, but I won't go into too much detail there. So what you see here is when we call this at architectures registry with the string custom neural network 1, we can see in the Python definition that we need an output width there that needs an integer. And so we have to define that output width parameter, this integer, in the same block in this configuration file. So that's the way that it's being resolved bottom up. And the other cool thing is, instead of calling this this decorator that we see on the previous slide, this at spaCy.registry decorator, you can also use entry points. And entry points are a little bit of voodoo magic for me personally, but maybe if Guido is still on the line, he can explain it better than I can. But the way you can use entry points is basically if you have your own package. So let's say we have the setup.cfg in your own package. You can expose some of the functionality in your own package, for instance, in your Python module architectures.py, and you can say that this specific function now should be or could be in spaCy's architectures registry. So this is just really another way of defining or adding functionality to the spaCy registry and allowing you to customize all of the functions that you can use in the configuration file and adjusting those to your specific use case. And more than that, it also allows you to, broadcast functions that other people can use as well. And you don't even have to call specifically into spaCy. You don't have to import it. As long as spaCy and your package are installed in the same environment, this will work by that built-in voodoo, as I said. And another feature that we're using, another cool Python feature that we're using now that we've finally been able to drop support for Python 2 are the type hints. Before in the meetup, Guido has also alluded to this, and I think it's a really cool feature because, and I think most of you will be familiar with it, but just to run quickly through it, is what you can do is if you define a function. Let's say we're reinventing the wheel here and we're just defining how to sum up two integers. We can specifically say that we want A and B to be of type int, right? So they need to be integers. And if we do that, and you would then go ahead and call this function with, let's say, a wrong type here, we're by accident, let's say, calling it with a string, then your IDE, I think at least most modern IDEs which have MyPy linting enabled, will be able to tell you that at this point the function was expecting an int, but it got a string instead. So this is preventing you from making bugs as you're typing them. And I'll agree that this is kind of, this example seems a little trivial, of course, but if you're thinking about the context of machine learning and having to define, many different layers where multidimensional arrays are being passed onwards and backwards and so forth, this becomes really helpful to at least catch, let's say, easy errors quickly, because that might otherwise result in hours of debugging, and I'm speaking from experience. So I think this is extremely useful, and this is something that we've been adding to spaCy for the new release. And the other thing you can do is when you have type hints, because there's now a whole I think a whole suite of software that is being developed that is relying on these type hints and that is making them more powerful. And in spaCy, specifically with the configuration system, we are relying a lot on the Pydantic software that is written by Samuel Colvin to do basically the data validation of our configuration files. So to give you just a quick example, we don't need to go through all of this, but let's say that we have this warm-up linear function that requires one of the parameters is an initial rate parameter that needs to be a float. And let's say that the user, by accident, had there a list of floats. The second that we will try to run this configuration file through spaCy, there will be an automatic warning or even an error that says, well, I can't really progress here because this initial rate is obviously of the wrong type. And I think that's extremely valuable because otherwise it would probably crash somewhere down the line, 10 function calls later, and it might not be quite as obvious what went wrong. So I think this is very powerful and useful. So let me just. So I think there's one more feature of spaCy v3 that I want to share with you. And we've already talked about the complexity of machine learning systems. One part of that complexity is all of the parameters that you have to handle and the hyperparameters and so on that we're now, I think, providing a more structured way of storing them and replicating them in the configuration file. But the other part of running machine learning experiments is that they are often consisting of several steps that you have to run in a certain order, and that needs to be correct. So I think this is an example script that many of us might relate to. So what this shell script does is it just downloads some data. It will process that that data set with some pre-processing script. Then it will run the spaCy training command. Maybe it'll also check what the accuracy is of that model, inspect it a little bit, and then package and deploy the final or the best model. So this is a kind of script that I think I could have easily written in my previous career. And I think what's problematic here is, let's say that you've downloaded this data and you've pre-processed it. You've run some training and then you want to change the configuration file slightly. You will end up with removing parts of this script or maybe commenting it out because you've already done the pre-processing and this is a step that you don't want to replicate. Or perhaps you're going on a holiday and you're telling a colleague to deal with this script, but let's not deploy it yet. So they have to go and find all the data sets, find all the custom scripts that you've written to make this work. And I think we've all been there at some point that it seems quite straightforward to just run the script. Well, it really isn't. So this is a challenge that we wanted to address in spaCy v3 as well, and for which we've basically come up with something called spaCy projects. And the way that spaCy projects deals with this is we'll define a YAML file that has all of these commands listed in a more structured fashion. So the YAML file has the data assets first defined, and they can be anywhere. They can be on the cloud, cloud storage, or locally, or you can download them from somewhere. But the key part is that this is defined in the YAML file. And then we can define some workflows. And basically, a workflow is just a number of commands that are run in a sequence. And then the commands are defined here at the bottom. So for instance, the train command will trigger the spaCy train CLI command. But what is nice is that you can also define that this command meets a certain set of dependencies and will also produce a specific output or multiple outputs. And so what will happen behind the scenes then, if you would run this YAML file, for instance, let's say you run the training script, if you've already done the pre-processing, the training script will automatically see that this pre-processing is already done, and the files that it depends on have not changed since last time. So it will just basically skip the pre-processing step if it can. So it's doing some cleverness for you there, and I've definitely thought about that. I would have saved a lot of time for myself if I would have had this while doing my PhD, because I think this is just a really nice way of working in a project directory, doing experiments, being able to track back and save all the results out and so on. And the way that spaCy projects work is, I think it's quite a difficult thing to present on a slide, so I would definitely advise that you go and check it out. But it's a little bit similar to the git CLI commands. We've already provided some example projects for you to go and check out, and you can just clone them. So with spaCy project clone, you can get one of those example projects, make a copy of it locally, and just play around a little bit and see what you can do. And typically, you'll first fetch all of the data, of course, and then you'll run one of the workflows that are defined in the YAML command. You can also push intermediate results to remote storage. You can even auto-generate a README file. There's quite a lot of interesting stuff to look at with spaCy projects. And then, because this meetup is all about contributing to open source, I just wanted to have a few more notes as well about how we, maintain our GitHub repository. So obviously, we have an issue tracker where people can come and report bugs, which hopefully doesn't happen too often. But we've also recently enabled a discussion forum, which is a new feature at GitHub, and one that I quite like, because I think the issue tracker is sort of focused on reporting bugs and on issues that we know that we should act on and that should be fixed and then hopefully closed. While in contrast, the discussions forum is much more a place where the community can come together and discuss things, collaborate over new features. You can also have this sort of Stack Overflow style to some of the subforums where people can ask questions or ask for help, for coding help or so on, and they can select the correct answer or the best answer that they've gotten from other users. So I really like the Stack Overflow feel to it and the fact that you can just go there and discuss things. And I'll admit that there's still some rough edges around this new feature in GitHub. I think it would be nice if there would be labels as well, like we have on the issues, and maybe a unified search as well. But I think all of this is still coming, and this is a relatively new feature that will be improved upon, I'm sure. Of course, while maintaining this open source library, we make sure that we write a lot of unit tests. All the bugs that come in, when they get fixed, we will always write a regression test that needs to obviously succeed on every build in the future as well. And while there's only 4 maintainers of us, so Meta and Ina as the founders, as well as myself and Adrian Boyd, we also appreciate a lot of the community contributions that we've gotten over the past year and past years. So we see that a lot of community contributions are being done around adding new languages to spaCy. So this is really awesome. I think I've lost track at how many languages we're supporting. I think definitely more than 50, where there's base support for tokenization of sentences in that language. And that is often thanks to community contributions. And there's also a growing ecosystem of plugins in what we call the spaCy universe. So all kinds of plugins, software, and other open source tools that people have written using spaCy, and that does some cool functionality that they can share with the rest of the community. So the spaCy universe is also quite rich in functionality. And then in the Explosion team, we're also maintaining various other adjacent libraries, such as our machine learning library Think, which we revamped recently and which was being released as the version 8.0, and which is completely, significantly rewritten. And I think is very cool as well. So Think is also open source and is basically the interface, let's say, between spaCy and other machine learning libraries such as PyTorch and TensorFlow. And one question that we always get when we present this is, I think, an obvious one. So how do you make money and how are you able to maintain an open source library for free? And the answer is really Prodigy. So Prodigy is our commercial product, and if you buy a license for Prodigy, you really get the software on your local machine. It's not some kind of cloud solution that you lease for a month or something like that. It's sort of the old-fashioned take on buying software. And the nice thing about Prodigy is also that it's like spaCy, it's also scriptable. So it's also a developer tool where developers can just write their own recipes. And there are some recipes available as well as open source, so people can take inspiration from those. But they can write their own, and then you would end up with something like you see here on the slide, where the machine learning model has predicted some named entity. So for instance, a date, a person, an organization. And then the human annotators can go and basically say whether it's a correct or false annotation. And you can have all kinds of recipes. You can also have ones where you can actually say what is wrong or correct them and basically make a better training set that the machine learning model can then learn from and improve on. And a commonly asked feature is also whether you can how to scale this up in a bigger team of annotators. And the answer there is that we're working on let's say an extension of Prodigy called Prodigy Teams, where you'll be able to collaborate in sort of cloud environments with other annotators, while still making sure that all of the data that you're creating, so all of the manual annotations, remain your own private data, of course. So because that is quite crucial in a lot of companies, that when you're annotating this data, that this data is yours and stays with you. So that's very important. I could say so much more about spaCy, Think, and Prodigy, but I'll have to direct you to our awesome link that I just learned about yesterday called spaCy TV, which will direct you to our YouTube channel, which has many videos and tutorials. And recently we added 3 new tutorials on the spaCy 3 features that will go in much more depth than what I've been able to do today. So do go and check them out. And of course, a huge shout out to the team. So from left to right, Matt and Ines, who founded the company, and Ines specifically, who's also helped me a lot with these awesome slides because she has such a nice graphical touch. Adrian, who works on spaCy mainly, and myself, as well as I do, I meant to say. And then Justin, who works mainly on Think and Prodigy, and Sebastian, who some of you might know from FastAPI and Typer. He's the creator of FastAPI and also works on Prodigy and Think. And then there's Walter, who does sort of, the daily administration and sort of assists with everything you can possibly imagine, including sending, thousands and thousands of stickers for free all around the world for our spaCy users, which is, I think, pretty much what he's been doing for weeks now. And finally, Huari, who has worked with us during her studies at university and who recently graduated and joined the team as a developer advocate. And if there's any questions, I'd be happy to connect further or discuss on Discord.
Cool. Thank you so much, Sofie. I think we have already some questions. Maybe we can just quick go through them. By the way, we're informed that some of your lovely colleagues were actually helping people and by answering some of the questions. So I don't know whether these questions are answered or not, but I think, Tanya, we have 3 questions to go. So should we start? Oh, Tanya, you're muted. We see you, but you're muted. Okay.
I don't know why my camera went out of focus.
Okay.
No, it's not going to happen.
You're good.
Anywho, I think before we jump into the questions, I'm going to say I love your slide deck. I always love all the spaCy explosion related slide decks. I've already mentioned this to Ines, but it's beautiful. Everybody loves it. And now, I think you already mentioned a bit on how you collaborate across projects. like how do you collaborate across all of these databases? Like, because you have all of your different products in Explosion, you contribute to open source, you keep track of what the community members are requesting. How do you organize all of this mess? What do you use, like Jira, Trello, anything else? Do you have structured sprints, being this a startup? Like, how do you make sense of all of the work that you do?
Right, that's a good question. So with respect to the slides, like I said, all kudos go to Ines, because she's really the graphical talent here, and then she's helped me put these together, because I could never do it as nicely as she could. But yeah, so with respect to coordinating all the projects, it is quite a challenge, because for instance, last year we started working on spaCy V3. And then as we started going, we sort of realized that we also wanted to revamp Think to be able to sort of work in the same philosophy as spaCy. So then at some point, I think, and this is usually Matt and Ines sort of laying out the path forward. So we decided to sort of bundle the efforts and started working on Think quite a bit in the team, and then basically got a release candidate out for Think, and then come back to spaCy and again work on V3, and sort of, bounce back and forth a little bit between the two until we get some kind of convergence. I don't think there's like really a magic sauce to it. I personally think that Matt and Ines are the magic sauce. They're just keeping track of all of these projects and being very hands-on and very involved with everything. And I often wonder how their head does not explode, but it works. So yeah, and so now the same thing has happened with the release of V3. Now we're again focusing more attention to Prodigy, so that Prodigy can work with V3 and make sure that everything aligns and gets up to date. So we don't really have official sprints as such. We did do sort of sprint-like week in Berlin last year, but this was just before everything hit with COVID. But other than that, it's mainly online, a lot of Slack messages and coordinating on some, to-do boards and these kind of things. But it's all pretty organically, I would say.
Cool. Great. But I want to get back to this, like the first questions that were pop up during your presentation. Awesome presentation, I should say. So what you can say about the following? Will there be a project template for creating a language that not yet exists in spaCy?
I want to say probably not, because the way that the spaCy projects work are that they call into functionality that you either write yourself or functionality that's provided by spaCy, but it's really a way to organize your scripts. Well, if you want to bring support for a new language to spaCy, you really have to go in and change the source base, right? You'll have to make a pull request, and you'll actually have to change the source code on the GitHub repository. So I don't think that you'll want to write a project that does that automatically. We're typically looking for users that have the specific language as a native language, so that they know what all the tokenization issues can be, and then can really help us define that language, because we feel strongly that this needs to be of high quality. So I don't think we could automate that somehow. But that said, we do have a lot of documentation on how to get started. Ines also has an issue thread somewhere that sort of outlines all of the steps, and we're always happy to help with any contributor who wants to come along. There's even a specific forum for that on the discussion forum about contributing to new languages. So we're always happy to help and guide you towards the resources that you need for that. Yeah.
Awesome. Thanks. Tanya? You're muted.
You're muted.
This happens all the time. Yes, I have, there's a question. I have dabbed with Chatted and Chatito to generate templated and labeled data. Is this an area that is being considered in spaCy or something like language generation as general topic?
Right. So if I understand the question correctly, I'm just reading it here in the chat as well. So to generate labeled data, that is pretty much what Prodigy does as well. So I showed you an example where you could say this annotation is correct or not correct, but you could also use Prodigy to label data from scratch if you'd like, and then use that data that comes out of that as sort of training data set in spaCy. So that's definitely a very tight integration that's already working today. Yeah.
Okay. But I think there's still, like, if we get back to this question, I think the second part of it is still, let's say, left unanswered. I mean, like, that's the question is, like, are you going to do natural language generation in the future or not? It's more like, it is a way to go.
I'm always a little bit skeptical about language generation. Like, what does that entail? What are you generating? What do you want to generate? I mean, what is the idea there? What is the context and the use case? So, for instance, I know that Rasa is using spaCy for their chatbots, which is a specific use case that you can think about, and where obviously spaCy can be of extreme value. But I'm not sure what generation model other than being just a transformer model that you can use for its features on a more specific classification task on top of that. I guess you could see it a transformer as a language generation model. You could at least use it as such. So yeah, I think you could do it. I've never worked on a language generation challenge or use case myself that I would sort of see how that would work. But yeah, you definitely could. It's just a broad question, I guess. Kind of.
Yes.
Now I'm wondering what my colleagues are saying in the chat. Maybe they're saying something completely different.
Cool. And I think there's like the last question that I saw there. And it says, which library integrates better with V3 for hyperparameter optimization? Is there something built in? Right.
So this we do have an example spaCy project for, because this is obviously a use case that a lot of people are looking into. And now with the configuration file where we've made all of the parameters explicit, you obviously can go and do hyperparameter search. That's always a fun part of your experimenting. So what we have in what you could, for instance, do is you could generate a set of config files and run all of those and see how the different models do. And we made a spaCy project example template that you can go to the website and just clone it and play with it. And this particular one, I'm trying to think of its name. Yeah, I think it's even called the hyperparameter search or something such. I don't know by heart. It will also log into the weights and biases tool. So I don't know whether you know that one, but it basically tracks all of the parameters that you've used during your machine learning training. And then if you make that connection, that's really powerful because you'll run all of your configuration files. Each one will be sent to each specific run will be sent to weights and biases, where you will see all of the parameters and you get all of these nice curves that will tell you, if you put your learning rate to that kind of number, it's usually better. If you put that parameter, if you flip that switch, it's usually better or not. So it's a really cool tool for doing hyperparameter search, and I would definitely recommend going through that project as sort of a starting point to get that started. Yeah.
Cool. And I see that we just get the last minute question popped up.
Oh, and since we're not gonna have a Python 4.0, can we expect a spaCy V4?
So personally speaking, I'm definitely hoping not anytime soon, because we've already spent quite a bit of time on V3, and we've spent a lot of time thinking about all of the different design choices that I've tried to outline a little bit here, and we've definitely built this one to last for quite some time. So there's a lot of customizability in the V3 that I think will allow us to go forward and tackle head on what else is new in NLP maybe in 2 years. hopefully it will still be able to deal with that in the V3. And I definitely felt Guido's pain when he was talking about, the incompatibilities between V2 and V3. So yeah, we're probably going to see a little bit of that for spaCy as well. But we've actually, so while a lot of the internals have changed, not so much has changed as for the user interfacing API. So if you want to convert from spaCy 2 to spaCy 3, I actually think that it's not that big a deal. So there's just a few little things to be aware of, and you will have to adjust your scripts. But it should be quite doable. I don't think it's as breaking as the Python 2 versus 3 feature. And yeah, so I think we're even offering commercial support for companies that are looking to make that switch from V2 to V3, and that need some help, with the switch. So there's definitely going to be support available to make that switch. So hopefully it's not. Hopefully it won't split into two communities like you said about Python.
Okay, cool. I think thanks a lot. First of all, it was the most beautiful and eye-catching presentation. And then just to present us what's really new, what's hot in the spaCy V3.
Sure, yeah, you're welcome. Thanks for having me.
And also for all these replies to the questions.
Thank you very much, Sofie. That was very, very interesting. And I'm sure folks are going to be super interested in following up with spaCy development.
Yeah, right. And now I think it's almost conclude our session for today. We just saw that the next meetup will be dedicated to a lightweight, fast and efficient language, Golang. So that will be the next one. For those who are interested, check in. And I think, yes, the last words that we want to share with our listeners, Tanya?
No, thank you all for tuning in and just putting up with us and our rambling for almost 2 hours. And thank you to all of the organizers for getting me invited, for inviting me and allowing me to be a host. And just a final note, please, if you're interested in Python and you belong to an underrepresented group, check out all of the different groups of PyLadies, all the different chapters of PyLadies. There might be one local to you, but also we have the remote chapter, and these days everything is virtual, so you can join any chapter activities. We have a lot of chapters around the world doing amazing things. That was my plugin.
Awesome, cool. Yeah, and then just thanks for mentioning PyLadies. Yeah, just as I mentioned, the new opportunities popped up with the virtual events, and we are pretty happy that last year we dared to do a Python online bootcamp, free of charge Python online bootcamp, and this year we want to repeat it and go a little bit more in depth with machine learning, probably with some basics of computer science with Python. So stay tuned as well. And thank you all for this session. Thanks a lot, I should say.
Thank you all.